Hello, my name is Grace. Today I'll be explaining how to do a sinusoidal problem. This one is taken off the winter 2018 final exam of the UW website. So, this one says the tides in Seattle are a sinusoidal function of time. The first high tide today, which is the maximum, was at 3 a.m. with a depth of 5 meters above low tide. Now, it also says that the first low tide was at 6:30 a.m. So that is going to be a minimum point. It is at 6:30, which converts to 6.5 hours after midnight. So that means we have our second data point here. And part A says write a function y equals f of t for the water depth today, t hours after midnight. Let y equal 0 be low tide. So this minimum value's y value is going to be 0. Okay, now we are going to find the four variables we need to write a sinusoidal function. So they are A for amplitude, B for period, C for phase shift, and D for mean line. The first one I like to find is the D value, which is the mean line. To find this, you will balance out or find the average between the two y values, the max and min. So to do this, you would do 5 plus 0, which is 5, divided by 2, which is 2.5. So that is our D value. Now, for the amplitude, or the A value, we need to find the distance between the maximum or the D line, or the minimum and the D line. So that would be 5 minus 2.5, which is 2.5. Now, for the period, we are going to subtract the x values of the max and min, which is going to be 3.5, and multiply that by 2, which is 7. So that is our period. And for our phase shift value, we are going to take the maximum x value, which is 3, subtract that by 1/4 of the period. So that would be 7/4. So that would come out to 1.25. Excuse me. Now we have our four variables, so we can write our equation now. So the sinusoidal equation is going to be y equals f of t equals amplitude, which is 2.5, sine quantity 2 pi over b, which is 7, quantity t minus c, which is 1.25. Close quantity, plus our d value, which is 2.5. So that is our function. Now, moving on to part B, we got today from midnight to midnight. For how long is the water at a depth greater than 6 meters above low tide? So we need to first visualize this. So imagine this is y equals 3. This is not entirely accurate. And this is our maximum. And this is our minimum at 0. Now, our sinusoidal wave is going to go somewhere in between these two lines. It's going to hit that one, yeah. So we need to figure out the times where it enters. So these purple points over here, we need to figure these out. Now, after we do that, we need to find the total time it is above those purple points. So we need to find the time shaded in purple over here. Now, okay. So first we need to find where it intersects. So to do that, you need to do y equals 3 and substitute y equals 3 into the sinusoidal function from part A. And then you just solve for t as I'm going to demonstrate over here. Okay. I'm going to subtract 2.5 from both sides, which makes 0.5 here. And then I'm going to divide by this 2.5 here. Now, to get rid of this sign on this side, we need to do an inverse sign to the other side, or to both sides. Okay. Now we just add 2.5 pi over 7 to both sides. Oh, whoops. And then we just need to multiply by the reciprocal to get rid of this value. So that is 7 over 2 pi. So this time value gives us this point over here, which is going to be highlighted in green. This point on the graph. Now, to get this other point, which the green arrow is pointing to, we need to find the symmetry solution. So this is the symmetry solution. And this green dot, what we just found, is called the general solution. Now, to get the symmetry solution, we need to find the vertex right here. And it's very neat that they gave us that point. It's the maximum over here. So that is an x value of 3. So we just need to find the distance between this maximum and the general solution, and then add that distance back to the maximum. So I'm going to do that right here. Okay, so our t value, our general solution, is going to be, let me calculate it. Alright, so it is going to be approximately 1.4743. I'm going to save that on my calculator as the letter A. Okay, so now we just subtract 3 from letter A, and then we just add it to 3 again. Going to do that right now. So that gives us around approximately 4.5257. So that is our symmetry solution. And this point is, let me highlight in a color. You can see this grade point over here. Alright, so to find these other values, these other points where it intersects the graph, we're going to make a very useful table to help us out. So these t values are from each period where it intersects, and to the left are the general solutions, and to the right are the symmetry solutions. So the general solution we found, the first time it crosses is 1.4743. And our symmetry solution is 4.5257. Okay, now to just all you need to do to get the second general solution is to add a period to the first one. So that will give us this green colored, this dark green color. Now, our period, as we found in part A, is 7. So you just need to add 7 to this general solution. And to find this other green point here, this dark green point here, you just need to add another period. It is very simple. Now, it says from midnight to midnight, so we need to keep adding periods until we reach 24. So Okay, now we basically do the same thing to the symmetry solution to find the second symmetry solution over here. Okay, so we've exceeded t equals 24. So what we need to do here, because this is a cutoff, okay, we're going to cut the graph off right at x equals 24. So we need to replace this 25 point something something with 24. Now, to get the total amount inside this purple shaded area, we need to subtract these values. Symmetry from the general. Oh, general from the symmetry. So symmetry solution subtracted by the general solution is the total time inside in one period. Okay, going to do that right now. Okay, so over here is 3.0513, and these values are all the same, so it's just going to be this 3 times. Now, for this one, it's a bit special because it ends in the middle of a period. So you're going to do 24 minus 22.4743. So that gives us 1.5257. Now we just add all these numbers up. Going to do that on my calculator right here. Okay, in total we have 10.6396 hours. And that is our solution right there. I'm going to make sure this solution is right. Yay! Woo, good job. Okay, thank you for watching.